Find the standard form of the equation for the hyperbola whose transverse axis has endpoints. Okay, transverse axis. That's the one where it touches the vertices. Ooh, so that means that these two things are vertices. Or whatever you just said. Okay, so -2, -1. Man, I think I'm just going to estimate. -2, -1. And +8. -1. So right down here. So if we were into crude drawings, it would look something like this.
Are we taking notes today, even though there's so many people
Psst. Hey, they can watch the video. Catch up with us. I know.
It's kind of weird with Will not here.
I know. We are will-less.
Who's the person of the day is Will?
Very funny, guys. What?
Well, we do ellipses.
No, we will not. No. Horizontal or vertical only.
Is that going to be next year's stuff? Is that even a thing?
Yeah, it is. It is a thing. It's a section in this book, but it is. We would definitely have to spend a lot more time if we were going to do that, which we're not. Okay, so the red hyperbola that I drew in there is just really rough. I mean, really rough. Do we know the value of, say, A? Or maybe we should identify the center first. What's the center? I got to vote for 2, -1. I don't think that's right.
1, -1.
3, -1?
Yeah.
Yep, that's halfway in between, isn't it? So you were close to the whole 2, -1. Right, the distance between -2 and 8 is 10. What's the value of A if 3, -1? The distance of A is 5. That's true. All right, the distance between 3 and 8. Okay, let's see what else they got here. The conjugate axis, that's the other one that doesn't touch the hyperbolas, has length 8. Has length 8. So how far up and how far down should I go from the center? 4 up, 4 down. Okay, so up to 3. And I didn't do a very good job on my scale here. So if we're going down 4 from there, that would be, what, -5? So what's the value of B?
4.
B is 4. Now I know in my poorly drawn scale that 4 and 5 look equal to each other, but they're not. Okay, sorry, I did a bad job of drawing. And we have our imaginary box. Yes?
What's the difference between the transverse and the conjugate axis?
Transverse is the one that touches the two. See, it makes a capital T. I'm just trying to make stuff up here, but the transverse one is the one that does touch the two. Transverse touches. They both start with T's. Okay? Conjugate is the one that misses everything. Okay, so we've got our box. What's so special about the corners of the box?
Those are where the hyperbolas store.
Yeah, you said it. You said it over here. Asymptotes. So you can tell that my really crude example of my hyperbolic branches was way wrong. I mean, we kind of had the right idea, but needed a little bit more specific touch. So we know A, we know B. What did they ask me for here? Find the standard form equation. All right. I think we have everything we need. What you got? Yep. X minus 3 over 25. Ooh, that's nice, right? Minus, okay. Nicely done. Very nicely done. Does everybody understand how we took our center and we did the top parts? We've got our a squared down here and our b squared down here. Now, a bigger question is, how do you decide whether the negative goes in front of the x term or the y term? Okay. If the y was positive, then it would be opening up and down, exactly. Since it was opening left and right, we knew that the x was the positive one. Okay, cool. It's almost like you guys already knew how to do that stuff. Awesome. Locating key points of a hyperbola. Do we know the center? I got to vote for -2, 5. Do you agree or disagree? You should agree. That is nice. All right. So let's see here. You probably should start drawing a picture. We've got an a value of square root 9, which is 3, and a b value, which is the square root of 49 of 7. Just for fun, can you tell me how to find c? Yes, 9 plus 49, right. We don't have to worry about the absolute value because we're not subtracting, we're adding. If you write absolute value, you will not be, nothing will be taken away from you, but I will be laughing behind your back. Okay, there will be a lot of snickering going on.
It's just more I have to learn.
Just slap absolute value bars everywhere. We'll be okay. Okay. So square root 58. Okay. Find me the vertices and the foci and draw me a cool picture, please. Go. Because we took the square root of 9 and we got 3.
Yeah.
Okay. So -2 and up 5. And so we went 3 to the right and 1, 2, 3 to the left. So we got the edges of the box that way. Now we're going to go up 7 and down 7 from there.
Wait, from the center?
From the center, because our B value was 7, so that meant we're going up 7 and down 7. Does that kind of make sense how we went? Left 3, right 3, up 7, down 7.
And what if you just draw a solid line for the graph?
Why do I what?
Would you count it wrong?
If you drew a solid line for the box?
Yeah.
It's not part of the graph. Just like these asymptotes that I'm drawing in right now are not part of the graph. Anybody have any questions about how I drew the box or the asymptotes? Is this going to open left and right or up and down? Left and right. Because the x squared term is positive. When I say that the x squared term is positive, am I looking here or here? In front or inside the parentheses? In front. That's what's telling me it's opening left and right. Well. So what are my vertices? Positive 1, 5. Right? 1 to the right, 5 up. Yep. And then what's the other one? Negative 5, 5. Now you were trying to use the plus and minus. Make sure you use it, correctly on the correct x. In this case, you'd be doing it with the x. What? We added the a value because we knew it opened left and right. So we just went 3 units left, 3 units right from the center. If this was opening up and down, we would have gone 7 units up and 7 units down. It touches the edge of the box. The vertex touches the edge of the box. So it's really important that we know whether it's opening up and down or left and right. Okay, how about foci? That's square root of 58, which is approximately 7.6. You add it to the, and subtract it from the x coordinate. So you said what? Negative what? Negative 2.
Not negative. Isn't it from the center?
Correct, but you have to go.
Oh, I meant like added to the negative 2.
Correct, so we're adding and subtracting. So 7.6, did you say? No, that can't be it.
No. I can't read my hand. What did I have? 5.6.
5.6. That's true, because if you add negative 2 to 7.6, you get 5.6. So 5.6, comma 5, and then negative 9.6, comma 5. That's true, because that would be the subtraction to find them. You're going that way, 7.6 units from the center, and that way, 7.6 units from the center. You have to find one vertex, or one focus in each branch. Now, something they didn't ask me about, but I'm going to ask you right now. What are the equations of those asymptotes? Equations of the asymptotes. Equations of the asymptotes. Asymptotically speaking. What are you thinking? Nope. Okay, folks, let's put our thinking hats on here. Do we know any point that both? Yeah, thanks. Do we know any points that both asymptotes share in common? Mm-hmm. The center. Thank you very much. So we're going to write these asymptotes at the exact same time using that central location. We do need to find the slopes of those lines. How can we find the slopes of those green dotted lines? We could go through the process of finding two coordinates and taking the y2 minus y1 over x2 minus x1, or we could just count. Whoa. Is it up 3 over 7? No, it is not up 3 over 7.
Wait, it's up 7 over 3.
Ah, up 7 over 3.
Wait, what's the other point you used? Like when you...
Folks, your B value here is 7 units, and your A value is 3 units. So you're going up 7 and over 3. So I know in my equation I'm going to have a positive and a negative 7/3. What do you think is going to go in these two parentheses?
Y minus... y plus 5.
Y plus 5? Good try. Good try.
Oh, it's a y minus 5 somewhere. And the x.
Remember, you told me that there is one point that they both share in common. The center. Any thoughts on this?
Yeah, y minus 5.
Y minus 5, good call. And? X plus 2. Oh, you mean so we actually use part of the standard form equation with the center and then just slap on a plus and minus in the slopes of the lines? Yes. If you have it in standard form, it should be very easy to write those asymptotes. You do need to find A and B, that's true, so you know your rise and your run for your slope. Now, this is no different than what we talked about before for eccentricity. We're going to find the eccentricity of the last example. Remember how we talked about it was distance to focus over distance to vertex. So, if I go back to that last example, what's the distance to the focus? You have it in your notes right in front of you, so go back and look. What's the distance to the focus? I think you said radical 58, didn't you? And what is the distance to the vertex? If it opens up and down, you probably are going to tell me 7. If it opens left and right, you're probably going to tell me 3. Which one do you think it is?
3.
Oh, okay, it opens left and right, so it's a 3, right? Nope. We're going to skip example 5 because it gets really, and example 6. So let's move into answering homework questions for you.
So we're not going to be doing this?
No, we're not. Okay. Anybody got any homework questions for me that we want to go over? Yeah, hold on. Let me get my my writing tools. Anything? What do you got?
I don't really. For number 10, just by like elimination, I got this graph to stay, but I don't understand why it's.
Okay. Let's look at question 10. What's the center? We're down here. What's the center when you look at that? 2, -1. All right. So 2 and -1. All right, there's the center. What's my A value? Square root of 9, which is 3. So 3 to the right, and 3 to the left. That's the edges of the box that way. What is the b value? Square root of 1, which is just 1. So that's 1 unit up and 1 unit down. So here's my box. Oops. Let's pick a different color. So I got asymptotes that go, why isn't it drawing? Okay, got asymptotes that go through the corners. Alright. Since the x term is the positive one, do you think it opens left and right or up and down? Left and right. So it touches the edge of the box and goes this way. So, kind of looks like that one right there. So what part was the confusing part there?
I think I flipped 9 and 10. These were 9 I got. Not sure how.
Yeah. 9 has to open up and down. Yep, no problem. Got another one? Another homework question? Any that you were struggling with? Huh? Number 5? All right. How do we change that to standard form? Divide by 12?
Yeah.
So that's x squared over what? 4 minus y squared over 3 equals 1. What's your center? 0, 0. Your a value? 2. Your b value? About 1.73. Well, 12 divided by 12 is, you're always trying to get it equal to 1 so you can see it in what we call standard form. So, you know, you got your center at the origin.
Wait, you actually did I just leave it in
Okay. No, if you're just trying to get a rough sketch, so you kind of understand, to make sure you know that you're doing it right, but you wouldn't have to. No. I'm just trying to match up the visual idea here so that people don't just blindly trust. I mean, I want them to look at the picture and go, well, that doesn't make sense. I wouldn't go up and down this time. I need to go left and right. I want that kind of magic moment to happen. Okay. How do I find the vertices? I am taking the x part of the vertex and adding 2.
I'm not allowed to discuss.
Yes.
I
Okay.
think good or bad.
I'm not
Nope.
allowed
Nope.
to
Nope. Don't talk about it. Don't talk about it.
Waylon, which test did you take?
He's not even allowed to tell you that. Okay.
There you go.
Can I borrow your calculator?
Because I'm not in shape.
Okay.
I saw you on a run Sunday.
Yes, and I
Okay.
almost collapsed.
Marvel owns the rights to the AP exam, so we're not allowed to talk about it.
So,
Okay. Do you understand why I went 2 left and 2 right from that? Just can't believe I just recorded all that.
Okay, so 0, 0, and yeah.
Okay. So 2 right, 2 left. And we would be going up to... Do I go up 2?
No, you go up.
Is it up 2 and down 2?
Oh, not quite up 2, is it? Because it's only up radical 3. Uh-huh. I have no idea why I chose brown. Okay. Is everything okay? Okay. Okay. Man, what is this? This is... Don't tell us about the test, please. Okay. We heard the whole spiel.
Was it hard though?
I just wanted to know if you like.
It was alright. It wasn't hard? Ah, you're going to jail.
Yep.
Okay, yeah, after that, I don't know what to do after that.
Okay.
Sorry.
All right. Neither does anybody. Okay.
And then you're done after this, right?
Then, so we know that it's going to do something like this. So where are you going to find the foci? Are you going to go left and right from the center, or are you going to go up and down? Got to go left and right, because you got to have one focus in each branch. You got to have one over here.
Okay, how come you never did that before?
How come I never put a focus?
No, I mean like, no, like, you see how you do that little curve thingy?
Oh, you mean why didn't I draw the dot for the focus?
Yeah.
Because I don't think the other examples even asked me for that. Oh, the one did, and I didn't put it in, did I? We found them, but I didn't put the dots on the graph. All right, I can do that.
Does the little loop thing go on the vertice or on the foci?
The loop thing.
My children.
The thing that says with an H.
The hyperbolic branch?
Yes. Does it touch the vertice or the foci?
It touches the vertex, yes. Because that's where it changes direction.
And then the foci comes after that?
Yes.
How did you get the vertex?
Okay, I did kind of indicate on the picture that we were, let's see here, let's close that out for a moment. I did indicate with the orange arrows that we would be going 7.6 units right and left. So that would put me, I think they told me 5.6, comma 5. And negative 9.6, comma 5. So you would have 2 points that would be focus 1 and focus 2.
Okay, but yeah, after you draw it, what the heck is called the vert or whatever that is?
Okay, the vertex is where the branch changes direction.
Vertices. I don't know how you got those numbers.
Okay, so you've got your center at negative 2, 5, right? So all we did was, since we knew it was opening left and right, we used the A value to go 3 right and 3 left. And those are the places where the branches will touch the edges of the box. It's got to come in, touch the edges of the box, and leave.
Okay, so the one to the right, you go down. You go right 1 and up 5.
Correct?
And oh, wow, I'm smart. I'm smart.
Self-proclaimed.
You did 23.
23, yes.
Yes.
23. Transverse axis is the one where it touches. So, ooh, let's do.
It's the one. It's the one that gate costs.
Let's do 25. 25. What? Gee whiz. Man, you're ruining all my fun.
We should do both. Because the transverse action should be, or axis.
Yeah, I think we should do 25. No, it should not.
Because it opens. say 1.5 or 15?
This is 15.
Oh, okay then.
We should do 23 and 15.
You should adjust.
Um,
Okay, so 0, 15, and 0, negative 15. These are the foci. What's your value of C? Or maybe I should ask this question, what's the center? 0, 0. Halfway between the foci. What's the center? Or the C value? 15, thank you very much. That's true. From the center all the way up to one of the foci is the value of C. Transverse axis is length 8. Transverse is the one that touches the hyperbola. So, is that vertical in this case or horizontal? It is vertical. So we're going up 8 units and down 8 units. Or am I doing that wrong? Should it be less? Says the transverse axis has length 8. Ah, it should be 4. Good call. Way to catch that. So, we know roughly, and I know roughly that it does this and this, and I'll erase those once we get our asymptotes in our box. But we know that it's changing direction right there at, what are the vertices there? 0, 4 and 0, negative 4. Yes, sir.
Does that mean that the
Are you sure? Okay.
yeah. Right, that means that B is
Okay, so we know our A value, or no, do we know our A or our B? We know our B value is 4. So now we can use our knowledge of C equals square. Maybe we should do C squared equals A squared plus B squared. What do we got there? 225 equals A squared plus 16. All right, what do you...
like I know the equation, but how do you solve that?
Well, don't you just subtract 16 and take a square root? So square root 209. Which is approximately 14.45 or 14.5. So that 14.5 is the edge this way, and the negative 14.5 is the edge this way, which creates our box. What's so special about the box? The asymptotes go through the corner. Find it in standard form. Okay. So let's write this equation in standard form. Let me get some white space here. Stop acting like you want to leave when we're doing work together. Seriously.
Y squared minus
We're
X
finishing this when we get back.
over
I know, this is Wagner,
16
did you not?
Huh?
Wagner, you have heard, did you not?
How do you remember?
0,
How did you know that though?
What are you saying over there?
I got secrets.
Who else is in that class? Because I don't remember.
Right, the distance from here to here was
Oh, I
15.
know Kate Ward was, right?
Okay, are you with me or against me? All right.
That's
All of them.
just kidding.
Yeah, I think I'm going to be Excel today.
What's gonna be what?
What's my equation?
Assault defense.
Y X.
If I do x squared and y squared, that would be correct, right? Because the center's at 0, 0.
X squared over 209.
X squared over 209. That's true.
Y squared
Well, that's a bad looking 0.
over Y squared
Sorry.
over
Y squared over 16 and what? Ooh, negative x, positive y. And that's question 25. The reason I wanted to do that one was it was the one that opened up and down, so I wanted to make sure that we had one like that versus since we did a bunch that were left and right.
Are you checking your home?
I am going to come around and check your homework.
Why?
Why?
I knew it.
Well, that's a bad idea.